Okay, let's start out with, this is the third lecture for dental public health. I have kind of combined two sections. We're finishing out the handout, the first handout that I gave you, and we're going to go right into that second handout, which is entitled Statistics. What we're looking at here is we've been talking about samples, mean, median, and mode, our nominal, ordinal data, this type of thing. How you present the data is critical also. You can do this with verbiage. In other words, in your research report, you can, in your conclusions or whenever you present the data that you collected, you can do it by describing it via words, but it's kind of difficult for a reader to read that much when you can use something like a descriptive or a visual representation of your data. And one of the ways to do this is to utilize a table, a graph, diagram, something like that. That makes it simple and concise. It's easier for your reader or the people that you are justifying your research to take a look, and very easily and quickly they can ascertain, they get a good idea of what your research results have come up with. This first illustration is a simple bar graph. In other words, you just have the bars, and it's talking here about the number of caries teeth, caries deciduous teeth for 8-year-olds. And so if you look here at the horizontal line at the bottom, we're talking 0 to 4 teeth, 5 to 8 teeth, 9 to 12 teeth, 13 to 16, and 16 to 20. And then you look at the vertical bar over here on the left, then it's very easy for you to say, of the individuals that you looked at, say 20 of them had 0 to 4 caries teeth. We look here and we can see 40 had 5 to 8 caries teeth. 9 to 12 caries teeth, we had probably 25. 13 to 16 caries teeth, 10 of those children fell into that category, and 16 to 20, we had maybe 5 of the children fell into that category. So if you had to explain this with words in a report, it would probably take you a page, page and a half to convey this information. And it would be real confusing. Your reader would have to probably wade through that once, maybe look at it again, and take it in sections. They can look at this. It's real simple. It's real concise. Now, we could present this in another format, which would be a histogram. And the histogram is basically a bar graph that the bars all touch. Same information, but we're looking here to where we're connecting them. Then you've got bar graphs with histogram characteristics. If you're looking at you're looking at like the number of caries teeth, but you want to divide your group into, say, ethnic groups, so that you're comparing two groups but looking at the same thing. You can see here the blue bar designates white, and the maroon designates Hispanic. So we're looking at two ethnic groups, and we're able to compare very, very easily in terms of the caries rate. We see the number of caries teeth in each one of the groups as they fall 0 to 4, 5 to 8, 9 to 12, so forth. But we can look at white, and we can also compare Hispanic. So we can get the numbers that we see in the group, and we can also compare these two ethnic groups to see, what are the similarities or what are the differences. Very easy to do that. Now, there's another way we can go too, and this is important if you're looking at more than 3 different variables or 3 different groups. You want to do something besides a bar graph or a histogram, because with the bar graph, obviously you can only look at one group. With the histogram, you could put your bars together, kind of combine the bar graph and the histogram, and you could look at maybe three different ethnic groups. You've got white, black, Hispanic. You don't want to go to a 4th group because then that gets your bar graph with the histogram characteristics. That's going to take it out too far. Then that starts to become too complicated as a visual representation of your data. So in that case, we want to look at a different type of visual representation. So here we've got this, and you can see what we're looking at would be bar graph, and then we're going to go to a frequency polygon. So with the frequency polygon, basically what you're doing is you're putting a dot at the top of each one of these bars, and instead of having the bars, you have a line graph that you're dealing with there. So it looks like this third chart down here, to where we just have a line, and that's called a frequency polygon. Now that works well with one, if you're looking at one variable, one group, but it also works real well if you combine more than one. So here we have our bar graph with the histogram characteristics that we looked at earlier. We could take that and connect the dots so that what it would look like would be something like this if we're looking at two things. If we're going to go with, I would say, 4 or more, greater than 3 elements that you're looking at, you're going to be best served probably going with a frequency polygon. There's also what they call a scatter plot, and a scatter plot would be to where you actually will plot. You have a line, you draw the line, and in terms of this, you plot each of your variables on this. This is kind of similar to what we're going to talk about with standard variations and things that we're going to be standard deviation that we're going to be looking at next, where you're plotting these things, and then you could say, do they group to the right? Do they group to the left? What's the relationship? And if you were to try to explain this with words, it would be very confusing to whoever you were presenting to try to convey this information, whereas you can use something like, a simple scatter plot. And it's very easy then for your reader or whoever's there in your presentation to determine or to get an idea of what you're talking about. Okay, so now what we want to do is get into the next packet that I gave you dealing with statistics. I had to rework this since I had to put more on these slides than normally would be on there, trying to explain as we go through, since I'm not there in person and my cursor can't point out particular things. So this may be kind of confusing. We'll kind of slow down a little bit and try to get through this. When we talk about statistics are, as we said, basically it's a way to put numbers to various things. It's kind of the study of numbers that we're looking at. And you've got two basic categories or classifications or branches of statistics. You've got descriptive statistics and inferential statistics. Descriptive statistics pertain to your sample only. So the statistical tests or manipulations, the things that we plug in that the computer spits out at us, if they're descriptive statistics, that means they pertain to the numbers that we got from our sample. Whereas inferential statistics, we want to take our sample results, our sample numbers, and be able to say, okay, if this is what exists in this sample, then this is what we're going to find in the larger population that we pulled that sample from. This is why it is so critical when you you're planning your research, that your sample selection, you have to have a good sample selection. You have to have everybody calibrated that's going to go in and, whatever they're going to look at in that population, that everybody's on the same page with it. Because if you have a problem with your initial sample, whatever you try to infer to the larger population is not going to be correct, because your sample wasn't really representative of your entire population. Now, when we look at descriptive statistics, we're looking at measures of central tendency and measures of variability, or measures of dispersion. When we talk measures of central tendency, that's the techniques that are used for finding the midpoint or the central axis of any mass of data. It's a way to describe a set of scores or numbers with just one number. So that if you pull out a DMFT scores for 100 kids, it's hard for us. We can't take those 100 scores and lay them all out and look at them and come to some kind of conclusion about them. This is where we're going to use statistical test, statistical manipulations, and we're going to end up with one number that's going to tell us something about all 100 numbers. And what we look at for this would be the mean, the median, and the mode. Those are descriptive type statistics. And so you guys have been figuring the mean is the average. And so you've been figuring the averages of things since you were probably in second grade. So you've been working with a branch of statistics since you were little bitty. So the term statistics shouldn't freak you out so that you automatically say, okay, that's math. I'm not good at math. I'm not, and then tune me out for this. I have put this, it's mean, median, and mode is what you normally say, but we're going to look at it for mode, median, and then the mean. We're looking at mode first because mode is it's the easiest measure of central tendency to compute. What the mode is, it is basically just the most frequently occurring score in a set of scores. And another way to say this would be the most frequently occurring variable in a distribution. And so the National Board or I may use either term in asking a question. We may say the most frequently occurring score in the following set of scores, or the most frequently occurring variable in the following distribution of numbers. So we don't want the terminology to throw you off. So if mode is going to be the most frequently occurring score, if we look down here at this first set of numbers, you've got 1, 2, 3, 4, 5, 3, 3, 7. Which number occurs most frequently? That's going to be 3. So that's going to be your mode. And so that's a real easy, most simplest way to compute central tendency, or to see, how all these numbers kind of compute together, or to tell you something about a distribution of numbers. Now, what if we look at this one over to the right of this set of numbers, and now we've got a distribution that includes 1, 2, 2, 3, 4, 5, 5, 6, 7, 8. If we look at this and we say, okay, we've got 2 2s, but we've got 2 5s now. So our mode is going to be 2 and 5. This is what we're going to call a bimodal distribution or a multimodal distribution. When we look at these things, you can have more than one mode in a distribution, but you can have only one median and one mean. So with your mode, you can have more than one. Now also with your mode, this is a nominal level of measurements. You're just naming. There's no mathematical relationship between these numbers. It could be that they just assign numbers to somebody, or they assign numbers via the color of their eyes. And, that's what you end up with. 1s are blues, 2s are browns, 3s are hazel, 4s are green, things like that. Now, we can also do below here where we've got blue, green, green, blue, blue, brown, brown as eye color, or it could be hair color. What is going to be our mode for this particular distribution of variables? Now, we say variables again because we're not looking at numbers here. We're looking at variables. These, you're not really looking at numbers either. Up above it, you can say variables because those numbers may not actually represent mathematical computations. In other words, your 3s aren't going to be 3 times as great as your 1s if you're looking at something that you're just naming. So if we look at blue, green, green, blue, blue, brown, brown, what is going to be our mode for this particular distribution of scores? It's going to be blue. So again, we're naming, it's nominal. There's no mathematical relationship between the variables. We're just looking to see which one appears the most often. So this is why we say the mode is the easiest measure of central tendency to compute. It's also the least frequently used measure of central tendency because it doesn't really tell you a lot, but it's, you can start that way and you can look. It is just basically useful in saying which variable is the most typical. And in a lot of cases, you can look at that and then you can kind of say, okay, if this occurs most often, say these are incubation periods, these numbers up here. And you've got 1 day, 2 days, 3 days, 4 days, 5 days, and 7 days. We could say, okay, the most frequent incubation period is going to be 3 days. That doesn't mean that, each one of those 3 days is going to be equivalent. And it doesn't mean necessarily that we're talking about 3 days is greater than or less than 7 days. It's just, it gives us variables. We could be talking about bowling balls down here. So it's just the most typical. You could say incubation periods. You would look at something and say the coronavirus. We look at incubation periods from exposure to the first symptom, and you get things like, obviously these are not correct in terms of exposure to the first symptom, but if you're looking at 1 day, 2 days, 3 days, 4, 5, 7 days, that is a way to gather that information, and then you can look at it and you can say, okay, the most frequently occurring incubation period for the coronavirus would be 3 days. So that kind of gives you a starting point in terms of gathering all your information and trying to organize it. So let's talk about the median now. The median is that number or that variable that is equal to or less than half the variables in your distribution, and at the same time it's equal to or greater than half the variables in the distribution. Basically what you're saying is the middle score in your distribution in a set of ordered scores. So what type of data is required here? It's going to be ordinal data. We're still looking at nominal data, but we have to take that naming data and now we have to put it in order. So particularly if we're looking at numbers like this, we want to make sure that it is ordinal, okay? So we put it in order, smallest to the largest. And then we're going to count, is it odd numbers or even numbers? Because that's going to tell you whether you're going to have to, if it's even numbers, you're going to have to add and divide. If it's odd numbers, it's going to be, the median is going to be one of the numbers that's in that distribution. If it's even numbers, it's not going to be one of those numbers in that distribution normally. You're going to have to add and divide those two middle numbers to actually get your median. So when we're talking the odd numbers, say we have something like this. We've got 18, 14, 25, 16, and 23. Okay, those are our numbers there. Now, if you looked at this and you would say 1, 2, 3, 4, 5, if you don't really understand this, you'll jump on it and you'll say 25 is your answer, okay? Because we're looking 2 here, so that gives us 25. 25 is not going to be your answer because what did we fail to do here? We failed to put it in order. We need to have that ordinal data. So what we do is from the smallest to the largest, and when we do this then, and we put 18 becomes our median. So I'll ask you and the board will ask you a question maybe to identify which of the, which of the following in the distribution is the median. And they're probably not going to give you something as long as this because they're not testing you on your ability to add and divide. But they could give you something like this, all right? And what they're looking at is so that you understand, you may remember that the median is the middle score in a set, of scores, meaning that it's the variable that is equal to or greater than half and also equal to and less than half. So it's going to be that middle number. And if you forget to put it in order, then you're going to select the incorrect answer there. Okay, so now let's talk about the even numbers. With even variables in your distribution, there's going to be some computation that's involved. So if we take, say, this distribution here, and we've got it here, and if we say, okay, first we've counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we know, okay, 10 I'm going to have to add and divide. So there's this many, 5 on one side, there's 5 on the other side. Now, in a case like this, then, we're going to select 23 because 23 is equal to or greater than half these numbers, and 23 is equal to, or this is equal to or less than, and this is equal to or greater than this half. But is this going to be correct if you put 23 down as your answer? What have we forgotten to do here? Ordinal data. We have to put it in order. So we have to take this distribution, all of these variables, and once we put them in order then, and we go, okay, there's 5 on this side, there's 5 on this side. So my median is going to fall somewhere in between here. This is where you have to take your 23 plus 28 equals 51 divided by 2. My median is going to be 25.5. That's what I'm going to be looking at then for my median. So you have to remember, it's easy to remember that the median is the middle score, but you've got to remember that it's in a middle score in a set of ordered scores, okay? The median also does not have to be one of the variables in the distribution. If you've got an even set of variables, an even number, and it's not going to have like above, if we had 23 and 23 together, it would be one of the variables in your distribution. But here, where it's going to fall between 23 and 28, we know that's not one of the variables. The mode has to be one of the variables in your distribution. The mean is not necessarily, and the median does not have to be one of the variables in your distribution. So let's look at this one again. So we've got 88, 72, 90, 76, 82, and 90, okay? First thing we're going to do is put them in order from the smallest to the largest. And then we're going to say, okay, I've got 3 on this side, I've got 3 on this side, I've got 6. So my median's going to fall somewhere in between 82 and 88. So if I take 82 plus 88, that's 170 divided by 2. My median is going to be 85 for this distribution of numbers. Okay, looking at the mean now. You guys have been working with means since you were little, okay? Because mean is just the statistical name for average. It's the sum of scores divided by the number of scores, your average. And what to remember here is the mean is affected by extremes, okay? Once we get to the mean, then we're talking about, we're not talking about nominal data anymore. We're getting in here where there's a mathematical relationship between the variables that are in your distribution. So if we look here in terms of, this set of scores, say these are hourly salaries for a dental hygienist. And so we go here, our mean, if I add all these together and divide by what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to get a mean of 2550. What is going to be my mode in this distribution? So if I look up here, I've got 18, 23, 26. Here's my second 23. 43, my third, my fourth 23. So my fifth 23. So my mode is going to be 23. Now my median is going to be what? What do I have to do the first thing? I have to put them in order. So if I look at this and I say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 variables here in this distribution. So with 10 variables, I know I'm going to have to do some computation. I'm going to have to add and divide because I've got 5 on this side. I've got 5 on that side. So what happens here then is this 23 This one is greater than or equal to half of the variables. And this one is this one is less than half, meaning that's less than the ones on the right. And this 23 is greater than the numbers on the left. So we're going to say that that's going to be 23. Now, if you do your mathematical computation, if you take 23 plus 23 equals 46 divided by 2, that's still going to get your 23. So if we look at this and we say, okay, our mean is 25.50 or $25.50, our mode is 23, and our median is 23. And if you're asking your employer for a raise, and say you're the poor soul making $18 an hour, and you think, okay, it's time for a raise, you approach your employer, and he's going to ask you, well, what's the going rate in this particular area? You want to do your research ahead of time so you can give him an answer. And what you may do here is you're not going to say the mode is, because that's 23, or the median is 23. You're going to say the average is $25.50, because that's going to be in your best interest. Where he may do the same research and he comes up with the same numbers, and he says, well, the mode, the most frequently occurring hourly salary in this particular area is $23. So we're going to go with the $23. So see, you're going to need to work with statistics and things as simple as, trying to ask for a raise, or a lot of times when you go in for an interview, they'll ask you, what do you think a fair salary is going to be? And so you want to come up with this type of information that you've got there. Okay, let's look here. We've got this set of salaries, and we know that the mean is affected by extremes, and we've got a big extreme over here. We've got, in this terms, if we look at 25, 26, 26, 26, 27, 48, and 52, this 48 and 52, that's really going to skew the mean, because the mean is affected by extremes. So if we go here and we add all these up, that ends up $230 divided by our 7 numbers. That's going to give us $32.86 an hour. What's our mode going to be here? We look up and we've got 25, we've got 1, 2, 3 26s, a 27, a 48, and a 52. So our mode is going to be 26. Our median, what's the median going to be? We know we're going to have to put it in order, right? And so we've got 1, 2, 3, 4, 5, 6, 7. I know if it's an odd number of variables, I'm not going to have to add and divide. It's going to end up being one of the variables in my distribution. So I look here, I've got 3 and 3. So this is going to be 26. So the median salary in this area is 26. The mode, the salary that occurs most frequently, is 26, but the mean is $32.86. Which one do you think you're going to present to your employer in terms of, are you going to say, well, the mode, most frequently paid salary is $26? No, you're going to say, okay, the mean in this area is $32.86. What's he going to present? He's probably going to say, well, the mode or the median is going to be $26, because that's going to work in his favor. So in terms of statistics, you'll see that people will manipulate statistics, manipulate it in such a way that it's going to represent what they're trying to do or what they're trying to say in the most positive fashion for what they're looking at. Let's look at one more. Down here, we've got 38, 36, 34, 40, 20, 28, and 28. Again, if we look at the mean, I'm just going to give you the mean here. It's going to be 32, because we know with the mean, the average, we added these up, and then we divided by 1, 2, 3, 4, 5, 6, 7. Our mode, we know the mode, there's 7 numbers there, right? So with my mode, I can look up here. We've got 138, 136, 134, 140, a 20. We've got a 28, 28, so the mode's going to be 28. My median, If I look at this, and remember, if you just look here and you go 3 on this side, 3 on this side, you know, you could say erroneously that 40 would be my median, but remember, we've got to put it's ordinal data. So once I put it in order from the lowest salary to the highest salary, I've got 3 on that side, 3 on that side. So my median is going to be 34. So in this situation, if you're presenting the stats to your employer and you're saying, okay, in this particular area, this is what the median salary is going to be, $34 an hour. You don't want to give them the mode. You don't want to give them the mean. The way the mean here is less because when we look at this distribution of numbers, we don't really have an extreme. When we look up here at the second distribution of numbers where we have 48 and 52, those are on the high end. So that's going to skew your mean up higher. I know a lot of times the newspapers, about every 4 or 5 years, they will publish something about the salaries of MSU faculty. And what they do is they're going to present it to make more of an impact. And they'll include the salaries for the folks who make over $100,000 a year. And in that list, you've also got the $30,000, $40,000, $50,000, $60,000, $70,000 a year bracket. There are more of those in that distribution of numbers, but those extremely high ones, they'll put that in because then that skews the mean and it makes it look like everybody's making, you know, $90,000 a year because you've got that 160, you know, 180, 130 a year salaries that are included with all of the peons down here that are making 30, 40, 50, 60,000 a year. Okay. Measures of variability or dispersion. What we're looking at this is we're looking at the relationship between an individual score and the other scores in the distribution. You do this whenever you look, whenever an exam grade is posted on the bulletin board back there, you look at your grade and then you look at everybody else's grade to see how your grade compares. First thing you look at is going to be probably the range. And what falls into measures of variability are going to be the range and standard deviation. This is what we're going to be talking about. The range is something that you've worked with. It's the difference between the lowest and the highest score in a distribution. So if the highest score is an 89 and the lowest score is a 67, your range, you're looking at 22 points as your range. If you've got the highest score is 98 and the lowest score is 58, you got a range of 40. That 40 means that there's a wider spread of scores. There's a higher measure of dispersion. And that dispersion means how the scores are spread out, that they're not all grouped on the high end or they're not all grouped on the low end. We've got 40 points there where everything is spread out over 40 points. Now, the standard deviation or standard is a variance, okay? It averages how far each score in a distribution or a set of scores deviates from the mean. So you're looking at how each score varies, or what is each score's relationship to the average of that group of numbers, all right? So normally what you'll see is you go out to 3 standard deviations. And the standard deviations, you have to find your mean. And let's say the mean is 80. You go out 1 standard deviation from the mean, and that's numbers that you're going to plot here. Now, the standard deviation, we're going to say we can go out, and usually what happens is about 99% of all your scores, if you've got a good bell-shaped curve, 99% of your scores should fall within 3 standard deviations of the mean. Standard deviation, what you need to remember is if I say 1, 2, or 3 standard deviations of the mean, that 1 standard deviation doesn't mean that's 1 point. 2 standard deviations doesn't mean it's 2 points, and 3 standard deviations doesn't mean it's 3 points. It's a standard deviation value. Your standard deviation, let's say in this case, is going to equal 7. And what they will do if they ask you this question is they're not going to ask you to figure out the value of a standard deviation, because to do that you need the computer. Let the computer figure that for you. If you had to do it by hand, it would take probably a page and a half of mathematical computations to get that value. So more often than they're definitely going to give you your standard deviation. They may not give you your mean. You may have to figure the mean. But if they do that, they're not going to give you 10, 11, 12 scores that you have to add up and divide to figure the mean. So more often than not, they're going to give you the mean and they'll give you the standard deviation value. So if we've got the mean here is 80 and we've got one standard deviation, and we talk about within one standard deviation of the mean, what we have to remember is that that one standard deviation goes above the mean or it goes below the mean. Okay, so that means here, if you look up here, 68% of your scores should fall within one standard deviation of the mean. And a lot of times people will forget to go below the mean. They'll figure one standard deviation and they'll only, add that one standard deviation and go above it. So what we're looking at here then, if we've got 80, and we know our standard deviation is going to be 7. That's our value. So 80 plus 7 is going to be 87. That's going to be your score that's going to be above the mean, okay, by one standard deviation. Then you're also going to do the same thing the other way, below the mean by one standard deviation. And that one standard deviation equals 7. So that's 80 minus 7 is 73. So if you've got scores that fall within one standard deviation of the mean, that means they're going to fall between 73 and 87. And that should be in a good bell-shaped curve. That should be about 68% of your scores fall within that one standard deviation. Then we go out to 2 standard deviations, to where we've got here sorry, had to close the door because they're shampooing the carpets. The 2 standard deviations, we come out to 2 standard deviations. And what that basically means is if we could take the 87 here and we're going to add another 7 to it, and that's going to be 94. Now, what we could also do is you can look at it a different way and you could say, okay, standard deviation is equal to 7. So 2 standard deviations is going to be 14. So I could take my mean plus 14, and that gives me the 94. So whichever way it's easiest for you to figure, you can go, you could figure how your standard deviations before you even start plotting. You could basically say the standard deviation equals 7, so that's 1. 2 is going to be 7 times 2, that's 14. 3 is going to be 7 times 3, that's going to be 21. And then you look at, mathematically adding or subtracting from your mean based on, the level of standard deviation. So if 94 is here, when I go below, that's 66. So if you look at 66 to 94, that means that you look up here, 95% of your scores should fall between 66 and 94. That's 2 standard deviations of the mean. And you could do, the other here, I could say 14, so 80 plus 14 is 94. 80 minus 14 is going to be 66. So now here we're looking at 3 standard deviations of the mean. And remember, it's going to be basically 99% of all your scores should fall within 3 standard deviations of the mean. That means you've got, a good spread of scores. So if we look at 3 standard deviations, again, if you take this 94 plus 7, that's going to give you 101. And then the 3 standard deviations over here, if I take my 66 and I minus 7, that's going to give me a 59. I could also do it the other way, to where 3 standard deviations equal 21. So 80 plus 21 gives me 101, and 80 minus 21 gives me 59. So that's what you're looking at, saying that almost all of your scores, 99.7% actually, should fall within 3 standard deviations of the mean. So 68% within 2 standard deviations. Look up here at the top of the blue, 95% or 68% within 1 standard deviation. That means 68% of your scores will fall either 1 standard deviation above or 1 standard deviation below. Then we get to 95%, and that's for your 2 standard deviations. So 95% of your scores should fall within 2 standard deviations. That means 95% of your scores should fall between 66 and 94. Then we get up here to 99% should fall within 3 standard deviations, and that's between 59 and 101. Normally the board will ask you a question like this, and they'll just say, in a normal distribution, how many of the scores should fall within 3 standard deviations of the mean? And you could say 99. Now they may say 98.7, and they may not actually have a 99%, but you know enough at this point to say, okay, if it's close to 99%, that's going to be 3. 95% is going to be 2, and 68% is going to be within 1 standard deviation of the mean. Okay, so let's look at this then. A question that you may get is, here we have a distribution of scores: 67, 82, 87, 64, 80, 91, 85, 88, and 88. Simplest thing, what's the mode of the distribution? If we look up here, we've got 167, 182, 187, 184, 180, 191, 185, and we've got 2 88s, right? So that's going to be, where are we here? 88 is going to be your mode. Median of the distribution. We know the median is going to be that middle number, right? So what's the first thing that we have to do when we're doing this? Is we need to put it in order from the smallest to the largest. And if we do that, then the next thing is we count 1, 2, 3, 4, 5, 6, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 scores, so I know it's going to be one of these scores here in the distribution. I don't have to add and then divide. So what I'm looking at here is 1, 2, 3, 4. 1, 2, 3, 4. That gives me 85 is my median. So now what is the mean of the distribution? Okay, and to get the mean, we'd add all these up and then divide by the number. And I'm going to go ahead and give you 81 as the mean. And I'm pretty sure that if they have more than 3 or 4 scores, they're not going to have you figure the mean. They're going to give you that. The standard deviation is 6.4. So with the standard deviation, we could look at it from a standpoint of 1 standard deviation is going to be 6.4 points above the mean and 6.4 points below the mean. 2 standard deviations, 6.4 times 2, that means 12.8. So that's 12.8 points above the mean for 2 standard deviations, 12.8 points below the mean for 2 standard deviations, and then 3, the same thing. We're going to end up with 19.2 points. So here's the question: how many scores are above the mean by less than 1 standard deviation? Okay, first thing we're going to have to do with this then is we're going to have to plot these scores out. We know our mean is 81, and we know we're going to go out 1, 2, 3 standard deviations to the right, and 1, 2, 3 standard deviations to the left. So if I take this and I say 81 minus 6.4, it's going to be 74.6. This next one, I could say 81 minus 12.8, and it's going to be 68.2. Third one, 81 minus 19.2, 61.8. I could too, at the same time, if it's easier, you could say 81 minus 6.4 is 74.6. And then I could take the 74.6 minus 6.4, and that's going to give me 68.2. 68.2 minus 6.4 is going to give me 61.8. It's whichever is going to be the easiest way for you to compute that. So then on this side, I've got 81 plus 6.4. That gives me 87.4. 81 plus 2 standard deviations, 12.8. That gives me 93.8. And then 81 plus 19.2 gives me 100 here. So I have plotted this out to where between 74.6 and 87.4, that's all 1 standard deviation. That's all the scores that fall in between those two numbers fall within 1 standard deviation of the mean. 93.8 and 68.2, all the scores that fall between those numbers fall within 2 standard deviations of the mean. And 61.8 and the 100, all the scores that fall between those fall within 3 standard deviations of the mean. So the next thing we have to do then, if they want to know how many are above the mean by less than 1 standard deviation. So we look here and we say above the mean, that means greater than 81, but it's less than 1 standard deviation. That means it's less than 87.4. So it's going to be greater than 81, but less than 87.4, because you're asking how many scores are above the mean by less than 1 standard deviation. We're not saying within the mean, because if we said within the mean, we would be looking from 74.6 to 87.4. We're talking just about above the mean. So what we have to do now is plot. So this first plot is going to be 64. We've come up to our distribution up here in the box, the upper right. I've got 64. Then I'm going to plot 67, 80, 82, 85, 87, 88, and 88, and then I've got 91. So those are my numbers there. So looking at these then, how many of these scores are above the mean? That means above 81 by less than 1 standard deviation. Our 1 standard deviation is going to be 87.4. So how many of these scores are greater than 81 but less than 87.4? And we come up here and we look and we've got 82, 85, and 87. So above 81 but less than 87.4, we've got 3 scores. That's going to be the correct answer for that. What if they ask you how many are within 1 standard deviation of the mean? So we know 1 standard deviation of the mean is 6.4 above the mean and 6.4 points below the mean. So that falls between 74.6 and 87.4. That's 1 standard deviation of the mean. Think of that there. So how many scores fall are within 1 standard deviation? So we come up here and we look now and we say, okay, starting at 74.6, we go, there's 80, that's 1, 82 is 2, 85, and 87. So the answer there is going to be 4. How many are between 87.4 and 74.6? And they say within. That means you count that number, 74.6, or if we had an 87.4 score, you would count that 87.4. Those aren't less than 1 standard deviation. They're within 1 standard deviation. How many are within 2 standard deviations of the mean? Okay, with 2 standard deviations, we know that that comes up to 12.8 points. How many are above the mean by 12.8 points? Because our standard deviation equals 6.4. And if we're looking at 2 standard deviations, that's 6.4 times 2. That gives us 12.8. So how many fall within that 2 standard deviations? If we're talking our range of scores then is going to be between 68.2 and 93.8. So if you look at this and let's count them then up here, we've got 1, 2, 3, 4, 5, 6, 7. So between 93.8 and 68.2, 7 of the scores fall within there. And if you looked at that and you kind of did this out, you would see that it's not really going to be a nice bell-shaped curve. Okay, we're going to have a skewed distribution here because everything is falling. Most of them are falling above the mean. So we're going to look at that in just a minute. Now, if we look here then, and we look within 1 standard deviation of the mean, we know that should be about 68%. 2 standard deviations of the mean should be 95%. And 3 standard deviations, we should have 99% if this was a regular, nice bell-shaped curve. But if we figured this, how many fall within 1 standard deviation of the mean for this particular distribution of numbers, you've actually got 44%. How many fall within 2 standard deviations? You've got 77%, and within 3, you've got basically 100%. 100% of the scores fall there. So this is going to give us kind of a skewed distribution here. With a normal bell-shaped curve, your mean, median, and the mode are going to be the same. When the mean, median, mode aren't the same, then you're going to have a skewed distribution. You're not going to have that nice bell-shaped curve that you're looking at. So it's going to look something like this with our curve. And you don't have this particular handout. I didn't want to put this curve, which obviously I haven't figured out how to make a nice symmetrical curve. But if we were to do a curve for the scores that we have here, you can see that it's not bell-shaped. It's going to be skewed to the left, all right? And we're going to talk about this skewed distribution. Okay, the following REB scores recorded for 10 students from the same dental hygiene program. So you've got something like this. They'll give you the scores, and then they'll say the mean equals 84 and the standard deviation equals 4. And then they'll ask a question, which of the following is the mode of the test score? Okay, that's going to be real easy, right? It's the one that appears the most frequently. So we've got a 76, an 85, got an 88, 92, 86. That's our second 88. 77 and 90, 78 and an 80. So our mode is going to be 88. We've got 2 88s. Which of the following is the median test score? So again, with this, you're looking at here, and we know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have to add and divide. But the first thing that we do is we're going to have to put it in order, right? Because if we don't put it in order, and I do this, where we say, okay, 1, 2, 3, 4, 5 on that side, 1, 2, 3, 4, 5 on this side, and I figure this, 86 plus 88, and I figure 87 here, that's not going to be correct, is it? I'm going to give you that choice down here because I'm going to try to see if I can catch you to where you don't remember to put it in order from the smallest to the largest. What we're going to have to do here is put it in order. And if we put it in order, it changes. So we have 85 plus 86. Now our median is going to be 85.5. So you got to remember that. Put it in order. Now, what if we have this particular one? They ask us how many of the test scores are less than 2 standard deviations of the mean. Okay, we know the standard deviation equals 4. We know our mean is 84. So we know within 2 standard deviations, we're going to go what? We're going to go out to the second mark on either side of the mean here. We know that the first standard deviation here is going to be 88. That's 92. That's 96. We go below 80, 76, and 72. Then what we're going to do here is we're going to have to plot them. So we've got 76, we've got 77, 78, got an 80, 85, 86, 88, 88, a 90, and a 92. So then we say, How many of the test scores are less than 2 standard deviations of the mean? We've got here, we know our 2 standard deviations fall from 76 to 92. So how many of them are going to be there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or less than 2. So that means we're not counting 76 and we're not counting 92. So they're less than 2 standard deviations, so it's going to be 8 is our number there. Now, how many of the test scores are within 2 standard deviations? If we say within, then we're going to count all of them, and that's going to be 10 there. Now, when we talk about skewed distributions, that means which way does it slide off into infinity, okay? I think we probably are going to have to stop here because I'm almost out of time. I will pick up at this slide for the next lecture session so that we can use this to start to look at what we're talking about when we're talking about a negatively skewed distribution and a positively skewed distribution.